Welcome to this class. Today I am going to continue the chapter Simple Machine of Unit 8 of Science and Technology, the subject Science and Technology of class 9. And before this class, I want to start with certain material. Look at this at the beginning. You have seen this in your daily life. What is this? You know, and this is screwdriver and this is rolling pin. Rolling pin is used in making roti, but this screwdriver is used to screw certain screw in certain place. And these are used in our daily life. Both of them are simple machine and they are used widely in different purpose. Now I want to mention the common feature of these two. In both of these, two cylinders are connected to each other in such a way that they have a common fixed point. We can see from this side, this is a point which is common for this cylinder also and this cylinder also. And here also we have a common point here which is common for this small cylinder and big cylinder. And both of them rotate around that common fixed point. This is the common feature of both of these devices. Here also this small cylinder is fitted with big cylinder. Both of them have common fixed point and they can be rotated around that common fixed point. This is the common feature of these two. And what are they exactly? These two are actually wheel and axle. Wheel and axle consists of two different wheels of different radius, but they are capable of rotating around a common fixed point. That is called coaxial cylinder also. Okay, after this, now we can define wheel and axle this way. What is wheel and axle? Wheel and axle is a simple machine which consists of two coaxial wheels of different radius. Or it can be defined in a little elaborated form also. We can say this way also. Wheel and axle is a simple machine which consists of two cylinders of different radius which can rotate around a common fixed axis. The smaller wheel is known as axle and the larger wheel is known as wheel. For example, screwdriver, spanner, handle of door, pedal of bicycle, steering wheel of vehicle, etc. are wheel and axle. Okay, now let's go through their example. We have lot of wheel and axle. What are they? This giant wheel is one of the example of wheel and axle. When it rotates, it appears like this. We sit in the seat of this giant wheel and it is rotated in this way. Here, the big wheel is called wheel, but its axle is at the center. And axle is rotating and axle rotates because of electric motor. Electrical motor is used to rotate the axle that rotates the wheel. And we enjoy this in different fair also. Now, let's talk about another example. This is another example. This is cartwheel. And there usually a bull when pulls this cartwheel, then the force is applied on this axle. And when axle rotates, then it rotates the wheel. This way cartwheel moves. Here bigger one is wheel, smaller one is axle. This is an example of wheel and axle. This is manual sieving machine. Manual sieving machine consists of a handle, and when we rotate this handle in circular path, then a big circular path forms that represents the wheel of this manual sieving machine. But at the center, look at this, here we have a rod. That rod also rotates, which is connected to this sieving part, and the sieving is possible this way. When we rotate this handle, then the circular path through which the effort moves is wheel and axle is the rod in the central part, and because of this rotation of this wheel and axle, the sieving machine works. This way it works. Okay, now next, this is kite spool, which we say latai. Kite spool is used to fly the kite, and if we apply force on this big wheel, then the distance covered by this big wheel will be the effort distance, and the thread which is wound around this circular path in between these two wheels represents the axle. But if we apply force on the rod, this wooden rod, then it works as the effort distance. I mean to say the circumference of the rod works as effort distance, and the load distance will be the circumference of this middle part of this kite spool. Okay, there are other example also. Look at this is pedal of bicycle. When force is applied on the pedal, then it rotates. The circular path through which the pedal rotates is wheel, but this rim of this small wheel is axle, which pulls the rear wheel of the bicycle with the help of chain. This is the working of this pedal of bicycle, and this is commonly used in villages. We are using this type of wheel and axle to pull water from the well. When the effort is applied on the handle and it moves through circular path, then the distance covered in the circular path is effort distance. In the same time, the rope which is wound around the axle rotates, and it pulls the bucket full of water outside the well. This way it works. There is another example also. This is doorknob. Doorknob, this bigger part is wheel, and a rod connected to this is an axle which is connected to the lock of the door, and when we rotate this, then we can unlock or lock the door. This is another example of wheel and axle. Okay, these are the common example of wheel and axle, but if we have to make a diagram of wheel and axle in the examination or any place, then how do we do this? I mean to say, how to draw the diagram of wheel and axle. I am going to show you. Okay, look at this. This is the wheel. The bigger cylinder is called wheel, I told you just before. And an axle is inserted into it in such a way that both of them can rotate in a common fixed axis. Now, a rope is wound around the wheel this way, and effort is applied on this rope, and another rope is wound around the axle but in the opposite direction than that of the wheel, this way, and the terminal of the rope is connected to a load this way. Okay, this is load, and here we apply effort, and this is wheel, and this is an axle. This is the simple representation of wheel and axle. If you are told to draw diagram of wheel and axle, you can draw this diagram, and it has just two components, this wheel and axle, and they are connected in such a way that they are capable of rotating around a common fixed axis, and both of them are wound with rope, and the winding is just opposite in axle than that of the wheel. And we apply effort on the wheel to raise the load connected to the axle. Okay, now what about the effort distance and load distance in wheel and axle? Let's talk about the effort distance and load distance in wheel and axle. If we pull this rope in such a way that the wheel rotates once around its axis, then what will be the distance traveled by the effort? That will be equal to the circumference of wheel. And at the same time, at what distance load rises up? When wheel rotates once around its axis, then axle also rotates once around its axis, and the load will be raised to a distance equal to the circumference of axle. This way, what can we say? Effort distance is the distance traveled by the effort, that can be represented at twice pi r, and capital R is the radius of the wheel, and distance traveled by the load can be represented by twice pi small r. Small r is the radius of the axle, and we know that the velocity ratio is the ratio of effort distance to the load distance. we are taught in previous class also. What is velocity ratio? The ratio of the effort distance to the load distance is called velocity ratio in the simple machine. Here, effort distance is circumference of wheel twice pi capital R, and load distance is circumference of axle twice pi small r. And ratio of these two is, if taken, then that represents velocity ratio of wheel and axle. And 2 cancel, pi cancel. It means velocity ratio is equal to radius of wheel. Radius of wheel upon radius of axle. What it means? We can conclude that velocity ratio in case of wheel and axle, velocity ratio is the ratio of the radius of wheel to the radius of axle, and it can be represented by capital R, and this can be represented by small r. This formula can be used to solve the numerical problem related to velocity ratio of wheel and axle. Okay. The same I want to represent by the formula and definition. What I told you just now, the ratio of the radius of wheel to the radius of axle is the velocity ratio of wheel and axle. It can be represented by this formula: velocity ratio equal to radius of wheel r upon radius of axle small r. Okay, have you noticed this? In different simple machine, this formula for velocity ratio is different. In case of lever, what I told you in previous class, the ratio of distance traveled by the effort to the distance traveled by the load is called velocity ratio in the lever. But it can be written this way also: the ratio of the effort arm to the load arm is called velocity ratio in lever. But it is different in pulley system. In pulley system, what is velocity ratio? The segments of the string or rope which support the load in the pulley system is called velocity ratio of the pulley system. But in inclined plane, what I told you, the ratio of length of the inclined plane to the height of the inclined plane is velocity ratio, because in different simple machine, effort distance is measured differently. That's why the equation of velocity ratio is different in different simple machine. But general velocity ratio, general definition for the velocity ratio is the ratio of distance covered by the effort to the distance covered by the load. Okay, after the velocity ratio of wheel and axle, now I want to tell you about the advantages which can be taken from the wheel and axle. What advantages can be taken from simple machine, and out of those, how many advantages we can take from a wheel and axle? I want to represent this. Look at this. Advantages of simple machine. It can magnify the effort. One of the advantages is magnification of effort. Another, it can change the direction of force in the convenient direction. This is another advantage. Another, increase of speed of the work. There are three major advantages which can be taken by the simple machine: magnification of effort, and change of direction of force in the convenient direction, increase of speed of the work. These are three advantages. Out of these three advantages, how many advantages can be obtained from wheel and axle? Now this is our question. Can a wheel and axle magnify the effort? Yes, it magnifies the effort. The reason is very simple. In every simple machine, effort times effort distance is equal to load times load distance. If effort distance is more than load distance, let's say effort distance is 2 units and load distance is 1 unit, effort distance is if more, then less effort will be able to raise heavy load, because the multiplication of left hand side should be equal to multiplication in right hand side. That's why if effort distance is more than load distance, then less effort will be able to raise heavy load. Now let's take it here. Effort distance is more or effort distance is less. The circumference of wheel is effort distance and circumference of axle is load distance, or we can say radius of wheel is effort distance, radius of axle is load distance. Radius of wheel is greater than radius of axle. That's why effort distance is more than load distance. That's why wheel and axle can magnify the effort. Wheel and axle can magnify the effort. This out of three advantages, magnification of effort can be obtained from wheel and axle. But can it change the direction of force in the convenient direction? Have you noticed that if we have to raise a body in the vertically upward direction, then we feel a little difficulty to raise the body in the vertically upward direction. But it will be convenient to pull a body in the downward direction. That's why, can we get this advantage from wheel and axle? Again, check it out. If we had to apply force to raise it in the vertically upward direction, then with bare hand certainly we'll pull it this way, vertically upward direction. But using this simple machine, we are applying force in the downward direction. What it means? It means this simple machine is changing the direction of force. This simple machine is changing the direction of force. Without the machine, if we had to raise this load, the direction of force becomes vertically upward. But when this machine is used, then we are applying force in the downward direction and load is raised to the upward direction. That's why this simple machine is changing the direction of force. This advantage also can be obtained by this wheel and axle. Okay, now let's talk about the third one. Increase of speed of the walk. Can it increase the speed of the walk? Let's check it out. To increase the speed of the walk, load distance should be greater than effort distance. If effort covers less distance, at the same time load is raised to greater distance, then speed of the walk is said to be increased. But here, if we pull this wheel and axle to a distance equal to circumference of wheel, then load rises up to a distance equal to the circumference of this axle, and this distance is less. That's why it cannot increase the speed of the walk, because effort distance is longer than load distance. Effort distance should be less than load distance to increase the speed of the walk. Okay, then out of these three advantages, third cannot be obtained by using this wheel and axle, but first two can be obtained by using this wheel and axle. Now let's go to another side. Wheel and axle is called continuous lever. Why? I want to tell you about this. Wheel and axle is a continuous lever. How it become a lever? This is the wheel and axle. If we see a wheel and axle from the side, then it appears like this. This is wheel, this is axle, and we have common center, and this is the common center for both the wheel and axle. If we compare this wheel and axle with lever, we can recognize this point as fulcrum because it does not move. And distance from this point to the circumference of wheel can be recognized as effort distance because effort is applied on the circumference of the wheel. This is effort distance. Or if it is a lever, we can say this is effort arm also. But the distance from common center to the circumference of axle can be considered as load distance because load is connected to the circumference of the axle. So, if we compare a wheel and axle with a lever, then this is fulcrum, the common center, and the distance from this common center to the circumference of wheel, effort distance, and this arm is called effort arm, and distance from this common center to the circumference of axle is load distance, and this arm is called load arm. It appears as first class lever. It can be recognized as first class lever. But when we apply effort, then it continuously rotates and the position of load and effort vary in 360-degree continuously. So, this is also known as continuous lever. We can symbolize this distance also. This is effort distance y and this is load distance x, and we can write certainly why this wheel and axle is called continuous lever. When wheel and axle is seen from its side and compared with the lever, the common center resembles the fulcrum. The radius of the wheel, which is denoted by capital Y, appears as effort arm, and the radius of the axle, which can be denoted by X, appears as load arm of the lever. Thus, it appears as first class lever. when it rotates, then effort and load vary continuously for 360 degree on the circumference of the wheel and axle respectively. So, wheel and axle is a continuous lever. This way, we can conclude that this is a continuous lever. Okay, I think you have noticed that in wheel and axle also we are using wheel, and in pulley system also we are using wheel. Then what is the difference between wheel and axle and pulley? I want to differentiate them with certain points. Wheel and axle, a rope may or may not be used in the wheel and axle. It is not the compulsory part of the wheel and axle. Rope may be used. In this case, rope is not used. Screwdriver, in this case also rope is not used, but in certain cases rope is also a part of the wheel and axle, but it is not compulsory, it is optional. But in pulley system, use of rope is compulsory in the pulley system. Whether it is only single fixed pulley or single movable pulley or double pulley or block and tackle, everywhere use of rope is compulsory. Second, it contains two wheels of different radius, not more than two, not less than two, just two. But in this case, it contains one or more than one grooved wheel. Third, the ratio of the radius of wheel to the radius of axle is velocity ratio in wheel and axle. I told you just before this. And in this case, the number of segments of the rope or string supporting the load is the velocity ratio in the pulley system. It was taught in previous class also. Okay, now after this discussion, I want to present one question, whether you will be able to solve this or not. A statement is given. Velocity ratio of wheel and axle is the ratio of the circumference of wheel to the circumference of the axle, which can be obtained by dividing radius of wheel by the radius of axle. Is it correct? The statement is correct or not? Just think about this. Argument 1. When effort is applied on the wheel to raise the load connected to the axle, then it increases the speed of the work. Is it correct? Now, next argument also given. When effort is applied on the axle to raise the load connected to the wheel, then it magnifies the effort. Is it correct? Now, looking at all these, you have to decide whether the option 1 or 2 or 3 or 4, which one is correct. Now, in option number 1, what is written? Statement and argument 1 are correct. Now, let's check it. Velocity ratio of wheel and axle is the ratio of the circumference of wheel to the circumference of axle. This is correct. Which can be obtained by dividing radius of wheel by the radius of axle. The later part is also correct. It means the statement is correct. But in this option, statement and argument 1 is correct told. That's why we have to go through argument 1 also. When effort is applied on the wheel to raise the load connected to the axle, then it increases the speed of the work. If effort is applied on the wheel to raise the load connected in the axle, if effort is applied on the wheel, then radius of wheel is effort distance and radius of axle will be load distance. Effort distance is more, and at this time speed of the work cannot be increased. To increase the speed of the work, load distance should be greater than effort distance. That's why argument 1 is incorrect. So, statement is correct, argument 1 is not correct. So, this option number 1 should be dropped. Now, option number 2. Statement and argument 2 are correct. We know a statement is correct. Now, let's go through argument 2. When effort is applied on the axle to raise the load connected to the wheel, then it magnifies the effort. Effort is applied on the axle, then effort distance will be the radius of axle, and effort distance is radius of axle, and it is less than load distance. Effort distance is if less than load distance, then it cannot magnify the effort. Effort distance should be greater than load distance to magnify the effort. That's why this argument 2 is also incorrect. So, we have to cut this also. Statement and argument 2 are correct. This option is incorrect. Now, third, both the arguments are correct, but statement is not correct, is incorrect. This is wrong because the statement is correct. Arguments are incorrect. So, we have to see number 4. Only statement is correct. Yes, after all, we came to the answer. What is it? Only statement is correct. both the arguments are incorrect. That's why we have to tick this. Okay. Now after this, it will be better to have a numerical problem because we have different equations. We know what is efficiency, we know what is velocity ratio in case of wheel and axle, and we know the mechanical advantage also. In previous class they were taught MA, VR and efficiency. In particularly this wheel and axle velocity ratio, what is it and what is this formula also told. So it will be better to have numerical problem. Look at this numerical problem. Radius of the axle of a wheel and axle is 6 centimeter. Radius of axle is given 6 centimeter and its efficiency is 90%. If 500 Newton effort is applied on the wheel to raise a load of 840 Newton connected to the axle, calculate the radius of the wheel. Numerical problem is very simple, but we have to write the information first given in the numerical problem. So I am writing this. What is given first? Radius of axle. Radius of axle is denoted by small r. We know this. This is 6 centimeter. And another point is given what? 90% is the efficiency. Efficiency is denoted by the symbol eta. It is 90%. And another information is given 500 Newton effort. Effort can be denoted by E. This is 500 Newton. Another information is the load. Load is 840. Load is 840 Newton. Now there is question. What is the question? Radius of the wheel. It is denoted by capital R. What is the value of capital R? We are going to find out capital R. Looking at all this information, we have to go through efficiency also. We have to go through load and effort also, it means mechanical advantage, and we have to go through this radius of wheel and radius of axle also, which is velocity ratio. That's why we can start with this. We have efficiency is equal to mechanical advantage upon velocity ratio. This we know from the previous class into 100%. This is the formula of efficiency. Now efficiency is equal to, I want to elaborate this, mechanical advantage is load by effort and velocity ratio is effort distance by load distance. But in this case, effort distance is radius of wheel and load distance is radius of axle. That's why R by small r into 100%. I want to simplify this. Eta is equal to load by effort into R goes up, small r goes up, and upon capital R into 100%. Now I want to put the value. Eta is 90% and this is equal to load. Load is given 840 Newton and effort is given this 500 Newton and small r is given 6 centimeter and capital R we are going to calculate into 100%. Now this 0 and 0 cancel, percentage cancel, and this 0 can be cancelled, this and this can be cancelled. If R is taken to left hand side, then R is equal to 84 into 6 centimeter divided by 5 into 9. 9 is taken to denominator. And 3 2s are 6, 3 3s are 9, 3 1s are 3, 3 2s are 6, 3 8s are 24. Now what we have, 28 into 2 is equal to 56 divided by 5 centimeter. And therefore R is equal to 5 1s are 5 and 5 1s are 5 again, 0.52s are 10, 11.2 centimeter. This is our final answer. Look at the final answer. What is the radius of the wheel? Radius of wheel is 11.2 centimeter. This way we can solve the numerical problem. Okay. Now I want to show you another numerical problem also, and I'll tell you how we can solve this. I'm not going to solve this because you can solve this very easily. The method of solving this numerical problem I'll tell you, but This numerical problem is easier than this one. The radius of wheel and axle are 9 centimeter and 2.5 centimeter respectively. And radius of wheel is 9 centimeter and axle is 2.5. If 150 Newton effort is used on the wheel to raise the load of 600 Newton connected to the axle, calculate the following: mechanical advantage, velocity ratio, efficiency. It's very simple. For mechanical advantage, we have to use load by effort. MA equal to load by effort. Here it is 600 Newton divided by 150 Newton. You can get directly. I can see the result is 15 4 4 will be the mechanical advantage. And to get velocity ratio, we have to use the formula. Velocity ratio is equal to radius of wheel upon radius of axle. We can take 9 centimeter in numerator, 2.5 centimeter in denominator, and we'll get velocity ratio. And for efficiency, eta is equal to MA by VR into 100%. And this is very easy. MA and VR both are calculated previously, and efficiency can be calculated easily. Okay. Now I want to go through another interesting question. Which of the following arguments is correct when a load connected to the wheel is raised by using effort on the axle? First, load will be less than effort because effort distance is less. Effort will be less than the load because effort distance is more. And effort will be less because effort distance is less. And last one, load will be more because effort distance is less. It's very, very confusing, isn't it? Now, let's see the question again and then we'll go through the option. Which of the following arguments is correct? When a load connected to the wheel, load is normally connected to the axle, but here it is connected to the wheel. It means load distance is more, but effort distance is less. And using effort on the axle means effort distance is radius of axle, which is less. Effort distance is less. Load distance is more. It means it increases the speed of the work. 1 point. It increases the speed of the work. If effort is applied on the axle, increases the speed of the work. Another point, more effort is needed to raise the load. Now, what are the options? Let's see from number 4. Why should we always go through 1? 4. Load will be more because effort distance is less. Load will be more, yes, because effort distance is not less. Effort distance is here more because effort is applied on the wheel. That's why this option is incorrect. Effort will be less. Effort never be less because effort is applied on the axle. That's why more effort should be applied. Effort will not be less. This option is also incorrect. Effort will be less in number 2 also. This is also incorrect. Load will be less. Yes, we will be able to raise less amount of load by using greater amount of effort because effort distance is less. We are applying effort on the axle, effort distance is less. This is the reason why we have to apply more effort to raise less load. That's why option number 1 is correct. Okay, today I finished wheel and axle. And what we learned about the wheel and axle? What is wheel and axle? Its definition, its diagram, its mechanical advantage, velocity ratio and efficiency. All these were calculated, and what is the velocity ratio of wheel and axle is taught. And I think you are helped by this class, and we'll meet in another class with some another matter. Now time is finished. That's why I want to stop. Thank you.